For page 48, this is going to be an extension of more examples for page 47, the fundamental theorem of algebra. So that's just what I title it, more examples. It states, if a plus square root of b is a 0, then a minus square root of b must be as well. So a plus square root of b and a minus square root of b are both irrational roots. So just remember that from the quadratic formula, we get negative b plus or minus the square root of b squared minus 4ac all over 2a. And so same thing, just like imaginary numbers and complex numbers came as a plus bi and a minus bi. You get two of them at the same time. Irrational zeros work the exact same way. So I'm going to get the negative b plus the square root version and the negative b minus the square root version as well. So a plus square root of b and a minus square root of b, irrational values of that are zeros will also come in pairs as well, not just the imaginary ones. So here's our example that we're going to work with. We've got two examples only. It says write a polynomial f of least degree that has x equals 2 and x equals negative square root of 3 as zeros, and f of negative 1 equal to 2. The reason it says of least degree, because technically when I go to write the factors of this, I could technically have x minus 2 to the third power, which would still give me x equals 2 as a value of my x-intercept. So instead, because it says of least degree, that means I'm going to write it as x minus 2 to the 1 power instead. So that's what it means by of least degree. And so to start this off, I'm going to write this in its intercept form or its factored form, which in this case is going to look like this. And because we have irrational root, x equals negative square root of 3, we know that x equals positive square root of 3 is going to be an x-intercept as well. So I have a total of 3 x-intercepts, and I'm going to write this in its factored form or intercept form. I'm going to tag along this a now. I didn't do that on the last one because it didn't tell us what a point was. However, this one does, and so we can actually find our dilation this time. So this is going to be what we did in Unit 2, where we plug in the point to solve for a. Exact same type of steps here. Before I go to do that, however, I am actually going to go ahead and start foiling some of this out. I definitely don't have to do this part. I could go ahead and technically plug in negative 1 and 2 right now. You're going to have to end up foiling these two eventually in order to be able to solve it. So I'm just going to go ahead and foil it right now. So when I go to do that, I'm going to use the foiling. Your two inner terms will go away. And so you end up with x squared minus 3 times x minus 2. If I end up foiling that again, I end up with x cubed minus 2x squared minus 3x plus 6, and I still have a on the outside. At this point, I'm going to go ahead and plug in that x equals negative 1 and y equals 2. Negative 1 cubed is still negative 1. Negative 1 squared is 1 times 2 is going to be negative 1 minus 2 now. Negative 3 times negative 1 becomes positive 3, and then plus 6. When I add all those together, I get a times 6 equals 2, so I'll divide both sides by 6 to get a equals 1/3. And so there are two different solutions I could possibly give, depending on if it wants it in standard form or intercept form. This one does not specify, so I'll give both, but you don't just need to give me one or the other. I don't really care which one you give me. This first one's going to be the intercept form, and the second one is going to be the standard form. So for the standard form one, I took this one, x cubed minus 2x squared minus 3x plus 6, because it was a 1/3 on the outside. Went ahead and distributed 1/3 to each of these coefficients, and when you do that, this is what you get as your result. And then your second example, the directions say to find an nth degree polynomial of, I think that's supposed to say least degree, with real coefficients satisfying the given condition. So it looks like I left off the word of least degree. It says that the degree is 3. No, it's not supposed to. Okay, so it says find an nth degree polynomial with real coefficients. So I don't need this word of at all. That shouldn't be there at all. So let's go ahead and take that one out. So we're going to get rid of that word. Okay, sorry for the confusion. So the degree of the polynomial in this case tells us is 3. Our x-intercepts, or our zeros, are -1 and 1 plus I root 3. And then we know that it passes through the point f of 2 equals 12, or 2 comma 12. So to begin this, we know, because that is a imaginary solution here, we know that his conjugate is going to be there as well. So far we know that 1 minus I root 3 will also be an x-intercept. If I put this into its intercept form, be very careful here. 2 of our answers or zeros are binomials, which means I need to put parentheses around it when I write my factored form. Remember, it's x minus the x-intercept, so x minus -1 becomes x plus 1. X minus, this is the whole x-intercept, that's why I've got it put in parentheses here. And I'll do the same thing for the second complex 0. Now I'm going to drop those parentheses. And then when I do that, I get minus x minus 1 minus I root 3 and x minus 1 plus I root 3 in parentheses, timesing by x plus 1 and a. Now, same thing is true here. I could go ahead and plug in my 2 immediately right now. There would be a 2 here where the x is, 2 here, and a 2 here. These are going to have to be FOILed eventually anyway, so I'm going to go ahead and do it now before I plug in that 2. But you very easily could go ahead and put a 2 in right now, y equals 12, and then start to solve for your a if you prefer. It doesn't matter to me. It may actually even be simpler. Now, this one is very, very, very tough when you go to FOIL this one out, so be very careful. This is what you end up with. So what I would do is I would pause the video for now and just double check to make sure that this is correct, that you get the same exact thing, because it is a little bit tough to get through this. So go ahead and pause the video now and FOIL that out. Then if we continue and collect our like terms, you'll notice you have a few things that are going to cancel out. So once you cancel out that I root square root of 3 times x and the I root 3, you also have this negative x and this negative x that come together give me negative 2x. That I squared will become -1. So when we put all that together, we've got a -1 times -3, which is +3, plus 1 becomes 4. So we now have x squared minus 2x plus 4 times x plus 1. Now if I FOIL this, oh, nope, it does not seem I FOIL it. I actually go ahead and plug in the 2 right now along with the 12. And so when I do that, I go to solve for my a after following my PEMDAS. And so here we've got 2 plus 1, which becomes 3, 2 squared, which is 4, minus 4, which is 0, plus 4, which is 4. So we have 4 times 3 times a, which is going to give me 12a, equals 12, which means that a is equal to 1. And so now, depending on what form you go to give it to me in, it doesn't matter to me which one you choose. Since a is equal to 1, you've got this form you could give it to me in, x plus 1 times x squared minus 2x plus 4. You can put it into this form if you want to go ahead and FOIL that out. This is going to be your standard form. If you do choose to give it to me in intercept form, you could also give me this form right here with the a replaced with 1. That would work as well. Okay, and that's it for this page.